Hello and welcome to this demonstration about how to modernize an application leveraging VMware Cloud on AWS and VMware Essentials PKS. So in our example, the company Commute Analytics has decided to move their data center to VMware Cloud on AWS. And they achieved an application migration already by leveraging HCX and the network stretching. They already moved their main application, which is an analysis tool for people which are commuting like every day to save time. The application consists of an Apache and PHP front end and a MySQL backend where they store the data. Due to the fact that they just leveraged HCX and migrated the VMs, they kept the IP addresses, and actually the application is running like before and is reachable by the users and commuteanalytics.corp.local. During peak times, users are still complaining like they did before that the response times of the application are really slow, and therefore Commute Analytics tasks VMware to do an application analysis. The application analysis did show that there is a limitation due to the current architecture of the application during peak times, and the front end cannot keep up with the actual load. Therefore, VMware suggested an application modernization leveraging Kubernetes. We bootstrapped the Kubernetes cluster onto VMware Cloud on AWS, leveraging Cluster API, which is the predecessor of Project Pacific. If I'm having a look here, I can see that our Kubernetes cluster actually consists of these nodes, and I can actually see that they are mapped one-to-one, so they are easy identifiable. For the load balancing, we actually integrated AVI load balancer to the Kubernetes cluster to provide load balancing functionality. And in terms of storage, we integrated the cloud native storage integration, which is per default there when you bootstrap a cluster with Project Pacific or Cluster API. So as we discussed, the limitation here is our front end. So what we're going to do is that we're going to breaking down this monolithic application and modernizing the front end of it. Therefore, we will actually create a container of the Apache front end, and we will leverage the existing configuration which we get from the VM. This will be included into our container. So let me quickly build this Apache container based on the PHP Apache stretch, which is already there, and tag it. Okay, our container is built now, and we pushed it already to the Docker registry. Yeah. The next thing we want to do is actually we want to go and deploy this application to Kubernetes. Like we said, we want to have an ingress, we want to have a load balancing service so we can access this application from the outside. So the first thing we want to do is we want to apply this YAML configuration file in order to create a front-end load balancer for this application. The next thing is that we want to actually create this application, and therefore we see in the deployment file for the application I've created a secret which is decoded for the MySQL path, and we're going to actually specify the container image which is built in the deployment, and we're going to specify the SQL host. If we're going back, you will see that this is exactly the IP address of the SQL host, so of the database VM which we are running here. So let's create this deployment. So currently, this deployment is in creation. So let me switch to the AVI integration and see what happened. So as we can see, the pool in AVI, which is created by the load balancer, is now backed by our actual pods which are running. If I'm going to access the actual IP address of the front-end load balancer, I will see that I'm accessing this Kubernetes deployment backed by the database, which is actually running onto a pod. At the same time, my application is still served by the VM which runs in there. This is realized because the front end is completely stateless, and therefore we can access our application by the VM and by the IP. Our users, of course, still accessing the application by the VM because this is what is in the DNS record. So what we want to do in order to move our users over to the pod-based deployment is we want to change our IP address on the DNS server. Now that we've done that, we can actually go and shut down the front end VM. If I'm opening another instance now of the Commute Analytics VM, I will actually see that this is now fully served by the pod-based deployment. So let's make use of the actual functionality of our new modern application, yeah, and leverage Kubernetes primitives to scale this deployment up. So what I want to do in terms, I'm expecting high load in the upcoming few hours. So I want to scale the deployment to 10 replicas in total. So if I'm having a look on the AVI controller now, then I will actually see that gradually pods are being spin up and added to the load balancer pool. Like we see now, we have 10 replicas running and serving our actual application. So we successfully transformed our application to a modern application using the MySQL database in the backend and a scalable Kubernetes deployment on the front end.